Monday, I'm not doing a thing other than going over homework. Monday is, here's a proof, do it. Here's a proof, can you do it? Here's another one, can you do it? Tuesday, review for the test. Wednesday, be careful, day off. Then Thursday, test. Whew, that might scorch some of you, that day off. All right, so Wednesday, day off. When we come back on Thursday, it's test day. All right, I'm not moving it to Friday because next Friday are shortened periods anyway. All right, so, all right, all good? That's the setup for next week. So today is the last fact and the last day of notes. So let's do this. The last fact is nothing new to us. The last fact, vertical angles are congruent. That's our last fact. So like we usually do, go ahead, get your statements, reasons set up. None of you have spoken up about this. I think it's okay. But sometimes I set up a proof not with givens and prove. I put an if-then statement instead. That whatever's with the if is actually your what? Givens, and then the prove. Then after the then is your prove. All right, we had a couple of them on the two on homework maybe. All right, so sometimes it's not the classic give and prove. Sometimes it's an if-then statement. And mark my diagram with 2 congruent to 3. All right, how can I get 3 and 1 congruent now, right? How can I get 3 and 1? I already know 3 and 2 are equal. I already know 3 and 2 are equal. Anything else you can tell me is true on this diagram? Because you're not going anywhere. You're not getting a 3 congruent or 3 and 1 vertical. Angle 3 and 1, are they vertical? No. I hope not. I hope we're going to say no. So I just can't go step 2, 3 congruent to 1, they're vertical. Nope, I need to do some more. So anything else based on this diagram is true up here. Anything else based on the diagram? Oh, please don't be me. 6, anything else true?
Angle 3 and 2. Oh, no.
Look at the numbered angles I've given you. I numbered them for a reason because I want you to focus on them. Any other relationship between any of these numbered angles? Specifically 1 and 2. What are 1 and 2 called?
Vertical.
They're vertical. So what do we know about vertical angles? So what can I say about 1 and 2? Angle 1 is congruent to angle 2. Good. I don't want definition of vertical angles. That's up there for a reason, to use it. I will not. I'm telling you now, that's not negotiable. I'm not going to take vertical definition of vertical. Vertical angles are congruent. Now the question is, how do I tie this all into 1 and 3 being equal? I don't want you to introduce anything else. I want you to use the work we have up here. Okay, givens. 2's congruent to 3. You just told me 1's congruent to 2. Can you tie those two together? Repetition? Repetition, huh? When we see repetition, what are we thinking? Oh, substitution. Look, angle 3 and 1 are both equal to 2, so they should be congruent to each other. And yes, that is substitution. That's substitution. You're going to get a lot of heavy dose of substitution today coming up. Anything about this one? Why it's not 2 steps? I have no idea what type of angles 1 and 3 are until next year. We're good here? We're solid. because this is a baby one. I'm going right to honors right now. This was a baby one. All right, here we go. Buckle up. So everyone's got M and N or X and Y congruent. And we got to get to M and N. Are M and N vertical? Absolutely not. This is not a two-step proof. Plus, why are we even doing this if they're just vertical, right? I'm not going to just give you this because they're vertical and we're done. All right, so I got to somehow get to X and Y. I'm sorry, M and N knowing X and Y are congruent. It's going to be a little tougher here. A little tougher. A couple days ago, I mentioned something about the givens. Remember that? I mentioned something about the givens. You will always use every single one, right? You're always going to use them. Now, why in the world would I have given you AEB and CED intersect? How would you use that? Well, here's why. If two lines intersect each other, what type of angles are formed? Vertical and supplementary, right? That's why I'm giving you this. Hey, wake up, open up the eyes, because on AEB and CED intersect, there's some type of vertical or supplementary going on with those two lines. Anybody see any type of angles I could possibly use here, maybe with X and Y to get to M and N? Just go ahead.
DEA and CED.
Everyone look at angle DEA and angle BEC. Let me mark them with arc marks here. DEA and BEC. Aren't those two vertical? And are anybody starting to pick up now what I'm going to do with those two with an X and Y to get to M and N? We'll talk about it in a second, but hopefully it's starting to light some eyes up now. But I'm going to write that first. Angle DEA is congruent to angle BEC. Vertical angles are congruent. Can we see it now that it's marked? How we're going to get to M and N now? What type of proof is this going to be? Subtraction. Whoa, whoa, whoa. How many pairs do you need to subtract? Here's one in the givens. And from the vertical angles we just wrote down. So the two pairs are there already. So angle DEA minus what angle from it? X is the same as taking the other vertical angle BEC and subtracting what from it? Angle Y. Yep. Subtraction. And shockingly, guess what the next reason is going to be? Substitution. To say M and N are congruent. One, two, three different facts, all in one proof. This is about as hard as it's getting. Questions here? How we got here? All right, one more. We need to take our time with this one. all set? We need to get to 4 and 6. 4 and 6 have no relationship, so it's not going to be a two-step proof. Plus, why would I give you all the givens? There are a lot of vertical angles up here, aren't there? A lot of vertical angles. I do not want you to put them all in one step. It's going to get so darn confusing if you just list off like 3 pairs of vertical angles here. You're going to have no idea what to do with them. So just give me one. Let's start with 1 pair of vertical angles. Preferably something that involves 4 or 6, because that's in our proof statement. All right? Giving me 3, giving me 2 and 5. I don't care. I'm looking for something with 4 and 6 here. All right, 4 and 6. How's it going?
3 and 6.
3 and 6. So 3 is congruent to 6. Vertical angles are congruent. Please do not give me any more vertical angles, because we need to come up with some conclusions on our own about other angles that are equal, because they're not vertical. Okay, so please don't write down any more vertical angles. It is just going to get more confusing. This is a lesson on how to use substitution properly. How many pairs of equal quantities do I have written in my proof right now? How many pairs? I have 3 pairs, don't I? When you use substitution, you need to make a decision. You can't use all 3 at the same time. You can only use 2. So I'm going to ask somebody right in a second here, pick 2 right now, and we'll use substitution on it. Basically, I'm asking pick 2 out of these 3 equals that have a repeating angle in it, and we'll use substitution on it. All right? So pick 2 for me. 5, pick 2 of these.
Angle 2 and 3 and angle 3 and 6.
Okay, we're going to use these 2 right now. Could I have used the first 2? Yep, I could have, but we're choosing 2 is equal to 3 and 3 is equal to 6. Using substitution, can you tell me what 2 angles are equal? 2 is equal to 3, 3 is equal to 6. What 2 angles are equal up here? 24? 2 and 6. Everyone ready? Angle 2 congruent to angle 6 because of substitution. If it helps you, I'm going to mark an X there that says, hey, we've used these already. Don't use them again. Look at what's left over now. Everyone see what's left over? I haven't X'd out yet. Can you tell me another pair of angles are equal without even mentioning vertical yet? 1's congruent to 2, 2's congruent to 6. That means, what other 2 have to be equal? 14?
Angle 1 and 6.
Angle 1 congruent to angle 6. What did we just do again? Again, guys, substitute again. I need to see these on separate lines. If you're doing it in your head, great, but I need to see each substitution on a separate line. All right, we just used that one and that one, so we're kind of done now, right? We're done, but I still need 4 and 6 equal. 4 and 6, and this is the only one I have left. So can you go back to the diagram and tell me 2 angles that are congruent, because they're vertical still? And remember, I have 1 and 6, but I need 4 and 6. Anybody want to try to connect it and tell me something about angle 4? Kyle? Angle 4 is congruent to angle 1 because they are vertical. Now look at the 2 I haven't X'd out. Got a conclusion? 1's congruent to 6, 4's congruent to 1, so therefore 18, finish this off.
Angle 4 and angle 6 are congruent.
Angle 4, angle 6, and what did we use to get to that conclusion? Another
Substitution.
Whoa, I'm not going anywhere. Is this the only way I could have done this proof? No. There's multiple ways of doing this proof depending on where you started. But again, I can't stress this enough. Do not just put a bunch of vertical angles in one step. You're not going to know what to do. If you have 3 equals listed, pick 2, use substitution, X them out. Then look at the 2 that are remaining and do substitution again and see where you go from here. I need every single substitution listed out in a single step. Questions? All right, go to your homework right now. Yes, you have 1 proof and 2 algebra problems. Yes, 3. 3 questions over the weekend. Look at number 3, please. Look at number 3. I want to make sure we are good and we're not going to skip it. Let's see, what is it? B, D, B, A, E, C. All right, first thing, don't make the mistake last period did. Questions 2 and 3 go to the same diagram. Okay, question. You don't have to draw your own diagram for 3. 3 belongs to diagram 2. Both those questions use the same diagram. All right, so in number 3, here's the deal. BEC equals Y, DEB equals 3x, DEA is 2x minus y, and it says find all 4 angles. All right, find all 4 angles. So I'm going to need x and y, and here's what's going to happen. Here's what's going to happen, and I'm only going to do one of them, and I'll let you go on your own. You're going to set up 2 equations with 2 variables, not these 2, but and going to have to solve it similar to what you did in Algebra 1 last year. Okay? That's what's going to happen here. We're not going to skip it or get scared. So right now, anybody know, give me 2 angles that have a relationship and tell me their relationship. Bridget, go ahead.
2x minus y and 3x equals 180.
So your first equation could be what? 2x minus y plus 3x equals what? 180, and maybe you want to clean that up to say what?
X minus y equals 180. Wait, sorry.
Combine your like terms.
5x minus y equals 180.
There you go. So that might be your first equation. Then you figure out another 2 angles that have another relationship. You write that equation, and by the end, you're going to have 2 equations with 2 variables on the same side that you got to eliminate one. And that's from Algebra 1 last year. Okay? So maybe I gave you your first one. When you get to it tonight, you come up with the second one. Make sure your variables are on the same side. Okay? Make sure x and y are on the same side, number on the other, and then you remember elimination, substitution elimination back in the day. You multiply the top or the bottom by a number, so you eliminate the variables. I'll let you go on that. Okay? We are good here. So you got a proof to do. And another warning, proof number 1, the only one you have to do is not 1 substitution. If you find yourself writing 1 substitution, you're not picking it up here and call me over. All right, it is not 1 substitution. All right, talk it over with each other. Let's get going. You got plenty of time. You know the deal. Work on it.